Distillation column is one of the important unit operations in many chemical industries and has been used from this inception of chemical processing industry. So, what is distillation column? Basically, distillation is a process wherein a liquid or vapor mixture or two or more substances is separated into its component fractions into its desired purity by the application of removal of heat. Method of separating mixtures based on differences in their volatilities in a boiling liquid mixture. In distillation column, the more volatile the liquid components are removed from the top of the column and the less volatile or heavier liquid components area removed from the lower part of the column. Method of separating mixtures based on differences in their volatilities in a boiling liquid mixture. In distillation column, the more volatile the liquid components are removed from the top of the column and the less volatile or heavier liquid components area removed from the lower part of the column. The distillation column is usually a vertical column where the liquid and vapor phases of the mixture are made to mix and approach the equilibrium. Therefore, the application or use for many commercial processes such as production of gasoline, distilled water, alcohol, and many other liquids. So, what are the types of distillation column? Number 1 is flash or equilibrium distillation. Number 2, differential or batch distillation. And lastly, continuous distillation with reflux. The benefits of distillation column is, number 1 is high purity products. Number 2 is economies of scale, use of low temperature and low cost energy. Number 4 is well-established technology and competitive supply of equipment. And lastly, well-suited for energy integration into the surrounding.
Our group has chosen distillation column in the term of PET because it has a lot of advantages, such as first, it is better for corrosive liquid, it is better for forming system, it is also have a high efficiency of separation, and lastly it has a very low pressure drop that reduces the cost in the industry. The basic operation of a PET distillation column is, PET distillation column has a larger surface area per unit volume to facilitate liquid vapor mass transfer. Liquid and vapor are in continuous contact on the surface of the PET bed. So, there are two types of design of PET towers, which is random PET tower and structured packing tower. The first type of PET tower is a random PET tower. Random PET tower use a variety of metal and non-metal materials such as ceramics and plastics. Materials provides the largest surface area for distillation to happen. Ratching rigs was the first packing that is used, but newer shapes has low pressure drops and large surface area per unit volume has replaced ratchet ring in PET distillation column. The next type is structured packing tower. Structured packing tower is manufactured from coagulated sheets of embossed metal, plastic such as PTFE and also wire gauze. This results in a very open honeycomb structure, which is vertical flow channels giving high surface area at lower resistance of the flow. The chosen surfaces maximizes the liquid spreading that shows significant performance benefits to the columns.
I'm and Arnie will show you the way to calculate stages of distillation column. To calculate stages, we need to use McCarthy method. Actually, McCarthy method is the mathematical graphical method for determining the number of theoretical plates or stages needed for a separation of a binary mixture of A and B. There are three types of reflux ratio, which are normal reflux ratio, nominal reflux ratio, and total reflux ratio. For normal reflux ratio, first step is plot equilibrium curve data and 45-degree line with its diagonal x equal to y. For step 2, we need to plot given composition, which is xf, xb, and xd. After that, we need to draw Q line from xf and yf. Q line is fixed line, so there are three conditions to plot Q line. Firstly, if boiling point is Q equal to 1, it means saturated liquid. If partially vaporized, the Q will be 0 until 1. So, to calculate the value of y, the formula is y equals to negative xf over Q minus 1. Last condition is, when Q is equal to 0, that means a superheated vapor. For step 4, we need to determine R from R over R min. For the step 5, we need to draw operating line for rectifying section. After find the ROL section, the next step is to draw stripping operating line section. The stripping operating line section touch the line XP. The next step is start stepping off from the distillate end until the intersection of the two operating line is passed, and continue stepping but use the stripping operating line. The next step is to count the number of stages. We must start from XD line. The first step is to draw horizontal line until it reaches the equilibrium curve, and draw vertical line until it reaches ROL line, and continue the same process until it reaches the Q line. Continue to draw the stages until it reaches SOL line. To calculate the number of stages, we must calculate from the XD line until the XB line. The last step is to subtract 1 for the reboiler to give the number of theoretical trays. The formula is the trays equals to stages minus 1. The other type of reflux ratio is minimum reflux ratio. It is different from normal reflux ratio, which is because the two operating line intersect on equilibrium curve. The last type of reflux ratio is the total reflux ratio. Total reflux ratio has no rectifying operating line and stripping operating line. Thus, to calculate the stages, the triangle must be drawn between equilibrium line and 45-degree line. To calculate the M minimum, we must use the Fensky equation, which is M minimum equals to log XD over 1 minus XD multiplied by 1 minus XB over XB divided by ln alpha average.
What is a definition of gas absorption? Gas absorption is a unit operation used in chemical industry to separate gases by washing or scrubbing a gas mixture with a suitable liquid. Next is simple fundamental. Firstly, mass transfer of the component of the gas from the gas phase to the liquid phase. Next, gas mixture is contact with a liquid for the purposely of preferentially dissolve one or more components of gas to provide a solution of them in liquid. Refer to this absorption column. Gas mixture is inert gas plus solute, while solute is transferred component.
The main purpose of absorption is to obtain or remove the desired component of vapor mixture with the usage of liquid solvent based on solubility characteristic of the components toward this liquid solvent. Example of application of absorption: first, removal of SO2 from state gas. Second, air pollution controls. Like the various oxide of nitrogen can be removed by absorption with water, sulfuric acid, and organic solutions. Third, removal of ammonia, benzene, and toluene from coke gas. To find the stages on the graph method, there are three steps that need to be considered to find the stages. First, we need to find the equilibrium lines by using the relations that given in the question. Next, we need to construct the operating line by plotting P1 and P2. And lastly, we have to find the number of stages on the graph. Okay, now I would like to show you an example question to determine the number of theoretical stages required to a separation of absorption column. Okay, after we calculate the flow rate of YA1 and XAN, now our job is to calculate the V1 and LN. Okay, after we find all this information of V1, YA1, LN, and XAN, we can proceed to our graphical method. Okay, in graphical method, as I mentioned earlier, there are three steps to find the stages. Okay, first, we need to find the equilibrium line by using the equilibrium relation that are given in the question, which is YA equals to 2.53 XA. So from that, we need to construct a table of XA and YA to find all the answer of YA. Yeah. P1 is denoted by XA0 and YA1, otherwise P2 is denoted by XAN and YAN plus 1. From that, we can find the stages by constructing 45-degree line starting from the P1 up to P2 by touching the equilibrium line. Then, the stages were being determined as 5 stages by counting it from bottom to top. So, the final answer of the stages of the multi-stage absorption columns is 5. Hi, I'm Nurul Asnaida binti Abu Hamdan. Okay, now I would like to show you about how to calculate the stages on absorption column. By the way, for calculating the stages on the absorption column, there are two methods, which is the graphical method and analytical method. Now, I would like to show you about how to calculate the stages on graphical method. Before calculating the stages, few things need to be identified, which are the type of absorption column, either it's single stage or multi-stage or packed absorption column. Then identify which one is the solvent, carrier, and solute. By the way, from the question, acetone is denoted by A, which is the solute or harmful gas, and B is denoted by pure air, which is and C is denoted by solvent, which is pure water. Next, we need to do overall mass balance of the liquid and gas in out.
in and out of the column. Next, we need to sketch the column to make it easier to us to know which are the in and out, which are the inlet and the outlet of the stream in absorption. Okay, next we need to find the amount of anterior acetone and air to the absorption column. This is the steps that need to be calculated to find the acetone and the air that enter the absorption column. As the conclusion, the 90% of acetone that was absorbed in the absorption column is 0.3 km per hour, and for the air is 29.7 km per hour. Okay, dah.
I'm going to continue Ms. Naida about how to calculate the multi-stage absorption column. There is two ways in calculating the multi-stage absorption column. So the first way, we use the graphical method, which has been explained by Ms. Naida, and I'm going to explain about how to calculate the multi-stage absorption column by using the analytical method. So firstly, what we should know that by analytical method, we use to calculate the absorption factor. So before we calculating the absorption factor, we have to find the overall mass balance. Overall mass balance, how to find the overall mass balance has been explained by the Ms. Naida. But in here, we only need the X value of the overall mass balance. So the first, we have to find the molar flow rate of the gas outlet stream and the composition of the gas in the outlet stream. The second, we have to find the molar flow rate of the liquid in that stream and its composition. Then we have to find the molar flow rate of the gas inlet stream and its the composition of the gas, and the liquid outlet stream. We have to find the molar flow rate of the liquid outlet stream and its composition. Okay, there's four steps in calculating the stages. With the step 1, we have to find the absorption factor by the A equal to L0 over M over V1. By the second step, we have to find the liquid outlet stream of the absorption factor, and the second, we have to find absorption factor. Well, the step number 4, we have to use the formula to find the stages of the absorption column. The final step calculating the stages of the absorption column, we can see in here that there is the formula for calculating the stages of the absorption column. So the formula is that n is equal to log yn plus 1 minus with mx0 over the y1 minus mx0 multiplied with 1 minus 1 over a plus with the 1 over a over the log a. So in here, the value we have to substitute in this equation. Then we can find the number of the stages. So in here, we find that the number of the stages is equal to the calculation in the graphical method, where the stages of this absorption column is 5 stages.